All right, looking at question 2, we are asked, generally speaking, would you say that most people can be trusted? Okay, somebody did a survey by the look of it, a random sample of 250 people in Chicago in the age group 18 to 25 showed that 45 of those people surveyed said yes to that question. They said yes, that most people can be trusted. Another random sample of 280 people, again in Chicago, but this time these people were aged 35 to 45, and of those 280 people, 81 of them said yes, most people can be trusted. The question is, does this indicate that the population proportion of trusting people is higher for the older group? We have to make a decision at an alpha of 0.05, and then down here we're asked to calculate a confidence interval. All right, now, keywords to look for. I'm talking about proportions. And we have two groups of people, younger group 18 to 25, and the old people who are 35 to 45. All right, we are looking to see whether the difference in the sample proportions is a significant difference. When you are comparing two population proportions, you always set this up as a difference. And I always try and set my difference up so that I get a positive difference. So I'm doing the old people minus the proportion of young people. All right, so proportion of old who are trusting minus the proportion of young who are trusting. There is no difference. That's my null. And my alternate, we are trying to prove that old people are more trusting than young people. If that is the case, then the proportion, or the rates, whatever term you want to use, should be higher for the old people than for the young people, in which case my difference will be a positive number, greater than 0. All right, so this one here implies no difference in the groups, and this one says old more trusting than young. Okay, and the alpha we are looking at is 0.05. All right, one of the first things you have to do when you're dealing with proportions is calculate the sample proportions. And I've already got that done. And here it is. So, all right, for my young people, I had 45 out of 250 said they trusted most people. That's 18% of them. And for my older group, 81 out of 280 and 29 of them, or 29%, sorry, said most people could be trusted. Now, looking at these two values, it does look like the difference is most likely going to be significant. And usually we're asked sometimes to give an estimate, or what's referred to as a point estimate, for the difference in the proportions. And the way we do that is we simply find the difference in the sample proportions. So the population difference in these proportions is approximately equal to the difference in the sample proportions, and that difference is 0.11. So there's an 11% difference, and really the question is that 11% difference a significant difference or not? All right, the test statistic is a Z. Your notes are showing that to be, hang on here, your notes are showing that to be calculated using this formula right here. Okay, so I'm supposed to look at the difference in my samples, and be careful how you do this, because the 1 and the 2 here should be in the same order as what you've got your proportions listed up here in your statement of hypothesis. So I've got my sample proportions, and down here, before I can do my calculation, actually, I got to calculate a pooled proportion. And let me see, I got that here somewhere. All right, here's my pooled proportion. So how do you get the pooled? You take the sum of, in this case, number of people in each of these samples who said that most people could be trusted, divided by the sum of the sample sizes. And that together gets me a pooled proportion of 0.238. So that value is being thrown down here. So 0.238 times 1 minus that value times 1 over each of my sample sizes. And if I work all that out on my calculator, I'm going to get a Z statistic of 2.97. Now this is an upper tail test, so my p-value is actually going to represent, like we looked at in assignment number 5, it's really going to represent the area to the right of a Z-score of 2.97, which I can go into Minitab and get using the probability distribution plot, but I'm not going to bother. I'm going to go to Minitab now and I'm going to run this test. Okay, so let's go to Minitab. Now, we are doing a 2 proportion test. All of these tests are under the Stat tab, Basic Statistics, and we are comparing 2 proportions. Okay, this window opens up. I don't have any raw data. Instead, what I actually have are summarized data. Now, I set up my proportion so it's old minus young, and of the old people, we had 81 out of 280. And of the young people, we had 45 out of 250. Okay, we go to options. All right. The hypothesized difference is 0. You could change it, but we're not being asked to determine whether there's a specific difference, so we're assuming no difference. And our alternate hypothesis is we're trying to figure out whether there's a positive difference. In other words, whether the difference is greater than the number that's right here, greater than 0. Now, you need to pay attention right here because when we do this, according to the method that's in your textbook, we're using a pooled estimate for the proportion, which is what I just calculated before I calculated the test statistic. Say OK to that and OK to that, and I'm going to copy and paste this now into my Word document. Hold on here a second. Alright, so coming to my Word document, here's my p-value right there, 0.002. All right, now, question. So I have my p-value, and by the way, my test statistic, according to Minitab, is 2.95. I got 2.97, but that's rounding error, so I'm not going to worry too much about that. Double check that this says what you want it to say. We are testing that the difference is 0 versus that the difference is greater than 0. Notice that Minitab has calculated for me up here my sample proportions, and it also gives me an estimate for the difference. Now, I rounded mine off to 0.11. Well, here it is at 0.109, blah, 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 blah. Okay, so question to ourselves is P less than or possibly equal to our alpha? What's our alpha? 0.05. Now, what do we got? We got a p-value of 0.002. Well, hello, that is smaller than 0.05. Anytime it's the answer to this question is yes, my p is smaller than 0.05, then I am going to reject the null hypothesis. Now, if I reject the null hypothesis, which is equal to 0, what am I really saying? I'm saying that the evidence supports the alternate, and coming back up here, my alternate says that I end up with a positive difference, which actually means for me that the proportion of older people who are more trusting is higher than the proportion of younger people. So yes, I reject the null hypothesis, and I conclude older people are more trusting than younger people. Okay, and I'll fix this up before I go post this. Now, the other thing we were asked to do was to calculate a 95% confidence interval, confidence interval, within which we expect to find the true difference in the trusting rates between older and younger people. All right, so now I want a confidence interval for the difference. And again, your notes are going to show you, hang on here now, I've got it done. Your notes tell you the formula for calculating the difference for proportions is given by this. So what do? You take the difference in your two sample proportions, you go out plus or minus some z-score. We're talking z, anytime we want to be 95% confident, the z-score is going to be that 1.96. And then I plug in my proportions and make sure you match up the sample proportion with the sample size. All right, I'll plug all that in my calculator and here's what I get. Now, I can go to Minitab just to make sure I got my math done right. I always double check this in Minitab because, hey, sometimes we screw stuff up on our calculator. All right, so if I want Minitab to give me the answer, I'm back into Basic Statistics, two proportions. And we want a two-sided interval because I said in the notes we're not going to talk about one-sided intervals. So make sure you change the difference to say not equal to and make sure your confidence level reflects your level of whatever it is you're looking for. Here we're looking for 95. So okay. All right, I say okay to that. And right here is my confidence interval from Minitab. So I'm going to copy that back in here, or paste that back in here. Whoops, come back up here. And let's see how they compare. So here's what Minitab's given me. I calculated 0393. It gives me 038 approximately. That's interesting. The upper endpoints are the same. The lower endpoints, there is a bit of a difference. But again, that's going to be due to rounding error. All right, so what am I really saying here? I'm really saying that somewhere between, I'm going to convert this now to a percentage because sometimes that makes our brains, whoops, that's a little bit easier for us to digest. If I convert those numbers to percentages, we got a 3.8% to an 18% difference. So what that really means is that older people are somewhere between 3.8 to 18% more trusting than the younger generation in Chicago. And that we really should specify because these were people chosen from a specific location. We can't make a generalized conclusion about everybody. Okay.